feel like I can't answer questions
I
because
feel
I'm like, I don't
we
want to
all
look dumb.
get filmed.
I mean, now I'm famous.
Well, 6 hour is my first time doing it, so sometimes I'm better my second time. But I often just forget. So that's why. Okay. Most of what we talk about today in the notes, you should have actually done this in geometry. So like inverse trig, you've already seen before. This stuff that I have, sine of theta equals O over H, cosine of theta equals A over H, and tangent of theta equals over A. That's regular just trig, right? So what you're doing is you have input an angle, okay, and then your output is a ratio. And we've done that lots of different ways. So if you think back, there was that time when I would give you a point on the terminal side. And I would say like 3, 5 is a point on the terminal side of your triangle. Find the 6 trig ratios. So you didn't really know theta. You could just draw it out and then find the missing side and label, either opposite, adjacent hypotenuse, or y, x, r, and do your ratios. We also did the versions like Friday where we have the special right triangles. So now I could give you a special angle, say like, tell me the sine of 135 degrees. And to draw the angle 135, find its reference angle 45, draw the triangle, then do the sine 1 over square root 2. Okay, so you're always getting an angle, whether you actually know the angle or not, but you're always giving me out ratios. Okay. What happens with an inverse trig ratio is you work backwards. Or you can also think about inverses undo things. So where we put in angles and got out ratios, now we're going to be flip-flopping that. We're going to put in the ratio. What if I know the ratio of sides? Then can I say what the angle is? So there's some new notations. Okay, you hopefully have seen these before. The inverse sine of opposite over hypotenuse. The inverse cosine of adjacent over hypotenuse. I could put x over r, y over r respectively there. And the inverse tangent of opposite over adjacent. You've seen that notation. Okay, so this is inverse tangent. That's how I say that. In quotes. And what happens there is you put in the ratio, whether you're putting in the ratio as a fraction or you're putting in the ratio as a decimal, but when you put in the ratio, then you get out an angle, okay? So it flip-flops. Your input is an angle, input is a ratio, and your output is an angle. Gosh, I'm having a moment where I can't remember the difference between algebra and pre-calculus. Did we do inverses first semester?
I don't think so.
No idea.
I actually think we did when we did radicals.
Maybe.
When we would if we had like y equals x squared, then the inverse was y equals plus or minus square root x.
Oh, yeah.
Okay, and so remember, the important thing to remember back when we did inverses was your first step is switch x and y. The inputs and the outputs, which, that's true here in our inverse trig functions. We're switching x and y. We're switching our input and our output. Okay, I'm going to make a little side note here. There's another abbreviation. So this is the one you've seen in geometry. I'm just going to write it on the board. You can choose if you want to write it in your notebook or not. I don't really use it much in Algebra 2, but you're going to see it next year in pre-calculus in Algebra 3. Sometimes instead of using that like -1, we use this phrasing arc sine, arc cosine, arc tangent. And those things just mean the same thing, inverse. So I should put in a ratio and I'll get out an answer. It's just another way to write it, which of course is like sometimes super annoying. Why would we give you more than one? And in pre-calculus, I always tell my students, I just need you to recognize it. So if it says arc cosine, you know that it means inverse cosine. You can always change it if you want. Okay, but those things are really the same thing. Now, okay, with your calculator, make sure your calculator is in degree mode. In degree mode. And see if you can do the inverse sine of square root 3 over 2. And to get the inverse sign, you're going to do the second button finally. Remember we talked about this earlier in the chapter because people want to use this for cosecant, but that's not allowed. Okay, so this is inverse sign. Oh, okay. Did you close your parentheses in the square root? Okay, do that.
I did.
Because if you don't, then it's doing the square root of 1.5, and we want it to do the square root of 3. And then divide that by 2.
I got an error.
I'm going two different kinds.
How about your pod members if they are getting errors in their calculators? Anybody getting one that's not an error?
No, I got 60.
60.
You said that like a
Alright,
minute
there we
ago.
go. What's that? What do we need to do if we're getting errors? Close the parentheses. That's not square root. You need to do 60. Is everybody getting 60? Help your pod members out.
What do I press?
Yes.
Who needs help?
Hold on, no, I'll figure it out.
Don't even talk.
Okay. I didn't.
Okay, so
That's right.
But 3. Close parentheses.
No.
Divide by
You don't need it. Okay, and then you that. But you didn't get 60.
Okay, which that makes sense, right? Look up here on my special right triangle. Actually, I'm going to draw it up here because I'm going to do it. On the special right triangle, where we have 60 degrees, the opposite side of 60 would be square root 3, and the hypotenuse would be 2. So that makes sense. And you kind of practiced that yesterday when you were trying to figure those things out backwards. Now, I'm going to show you something.
Big triangle.
Yeah, it is a big triangle. Let's say, like this side would have been 1. Let's say I like tripled the size of my triangle, but by a scale factor of 3. So this is 3 square root 3, and this would be 6. Okay. If you did the sine of that 60-degree angle, the sine of this 60-degree angle would be 3 square root 3 divided by 6. And then 3 over 6 would reduce to be 1/2. Yes, which would be square root 3 over 2. So like one point that you should kind of be aware of is it doesn't matter what size your triangle is. Your triangle could be small, medium, large, extra large, ginormous. Okay? If you're doing the sine of a 60-degree angle, it's always the same ratio, square root 3 over 2. And that's true for every single angle. That's true for 49.4 degrees. The sine, cosine, tangent of 49.4 degrees is set no matter what size the triangle is. Okay, so that becomes very helpful when solving. Okay, and that's because all triangles have a ratio to be a triangle. Okay? Let's just practice the other functions in the calculator. So if you'll type these in, make sure your calculator is in working order. I'll put my answers, and let me know if you don't get the same answer. I'm going to round to the 10th. Okay, make sure your calculator's working. Call me over if you're not getting those answers.
Got it. I don't know.
So now my ratio is written in decimal form instead of fraction form. That's
Negative 56.3.
Yes.
Are you doing inverse cosine for New Year? Oh, okay, yeah, that'll give you a different answer. Anybody having trouble with those? Okay, so I'm just going to make a side note right here. You'll talk more about this when you study inverse trig functions in pre-calculus or algebra 3. But notice that when you input a negative ratio into tangent or sine inverse, you get out a negative angle. However, if you put in a negative ratio for cosine, you get out still a positive angle, and your angle will always be between 0 and 180. For tangent and sine inverse, your angle will always be between negative 90 and 90. Now, there's a reason for that, but that you need to know more about your trig functions than we have right now. So we won't have to worry too much about that because we're going to use the inverse trig really for application purpose to solve problems. So ours are generally always going to come out to be positive angles. We won't have to worry about those negatives. Okay, but just kind of be aware. There is something strange happening in the calculator, and there's a reason for it. Okay, this is probably very similar to what you did in geometry. So if you want to sketch a quick triangle in your notes. Now, I could ask you in this triangle to tell me all 6 trig ratios. What would you need in order to be able to do all 6 trig ratios? Pythagorean theorem to find the missing side, and then you just do like SOHCAHTOA and flip them. However, I'm changing my direction. Instead of listing all the 6 trig ratios, can you now tell me what theta is? Yes. How will I do that?
You have the opposite.
I have the opposite and the hypotenuse. So in terms of SOHCAHTOA, you guys are telling me that's so, sine. Okay, so I'm going to write that up there. Okay, and then to actually get the angle, we're going to use what? Inverse sine, because we have opposite and hypotenuse.
Got it.
So we can say theta equals the inverse sine of the ratio opposite over hypotenuse. Just got my inverse. Type it into our calculator. What'd you get, Brianna?
I got 35.6, and then I'll round the last 9.
Okay, so I'm going to say 35.7, if you're okay with that. On these, I'd say round to the nearest tenth. That's fine. Is everybody okay with that?
Yeah.
If you are trying to find theta and you have the opposite and the adjacent side, I would use inverse tangent. If you have the adjacent and the hypotenuse side, I would use inverse cosine. I really don't ever use inverse cosecant, inverse secant, or inverse cotangent because why wouldn't I just flip it?
Right.
Yeah. All right. The last type of problem that you're going to see on your homework and that you should be prepared for, of course, is one of those beautiful word problems.
Wait, are we having a worksheet today?
Is that the back part of our worksheet?
Yeah.
Oh.
That was very smart.
Yeah.
Saved paper.
Okay, so one thing I like to do in these word problems, listen up, I'm almost done. One thing I like to do in the word problems is I just go to Google and I Google the thing that the word problem is talking about. I did that for like those inclines earlier in the chapter. But if you're ever confused by any of the word problems in the book, sometimes they get like, oh, they're going to tell you all about this thing. Just Google it so you get an idea of what you're supposed to be seeing. Like, there should be a triangle in trigonometry. Okay. But you've probably seen a truck-mounted crane like this before.
Yeah.
When things are building. So this is what we're talking about. And we can obviously tell where we could draw a right triangle, right?
Oh, enough chain there.
I looked away. I was looking. I was going for my eye contact. Okay, so we could draw a right triangle. Now I'm going to draw my own little truck.
School truck.
Yeah, it is. Okay,
Wow,
there's my
there's
truck.
my question on
That's
the
a
board skill here.
I know.
Wow. Watch this real quick.
The truck-mounted crane has a 200-foot arm. So that's this arm right here, right?
Right.
Okay, the arm of the crane is 200 feet. And its lower end is 5 feet off the ground. So like the arm of the crane isn't coming from the ground, it's coming from the truck, from the base of the truck or from the bed of the truck. And we need it to reach the top of a building over here where the building is 130 feet tall.
Plus 5. Minus 5.
Okay, so there is something to do with that 5 feet off the ground, right? Are you going to be adding 5 or subtracting 5? Subtracting, because when you want to draw the right triangle, think about your hypotenuse right here. You've got to create a right triangle there, and the 130 feet includes all the way to the ground, but we're starting 5 feet above. So this is really 125. Which trig ratio are you going to use?
There was no sins in math class.
Oh my god.
Jeez, TJ, chill.
You get it? Chilling?
No.
Okay, you should get 38.7.
38.7?
She's on top
Why
of
did I
it.
do
Yeah, she prepared.
Okay. Now, I actually really do, like, TJ, I'm glad that you said that because I would have said that had I been able to find my voice. I was having a coughing fit. It's sign, not sin. Yeah, so do the inverse sine. You'll get 38.7, and that's the angle that you should raise the crane.
Yay.
Okay? Your homework assignment
It's on the back.
is the back of that worksheet from yesterday. Just a quick reminder. I'm having trouble, so if you guys can just not talk while I talk, I would really appreciate it. Your quiz retake deadline for that first quiz is next Tuesday. When you're filling out that pink sheet and you're selecting a date to do the retake, I just want to put it out there. It's okay if you wait until the last day. You don't have to wait until the last day of the deadline to actually do the retake. So I've had it a couple of occasions first semester where people waited, scheduled it for the last day, and then they were sick or they had to catch a ride with someone else and all these other things. Well, then you've missed the deadline, and that's on you because you scheduled it for the last day. So if you have other availability, you might be able to take the quiz retake like Thursday after school, and that's perfect. So just know you don't have to wait until my deadline to do it. I'm not saying that you can't if that's the only thing that works in your schedule, but be aware that you have to keep your promise and actually show up at that time. The Chapter 9 test is scheduled for next Thursday. You can see over on the sideboard that our quiz is going to happen this Thursday, so tomorrow's going to be review. And then you're going to take a quiz on Thursday. I'm going to pass back your 9-3 concept check, and those corrections are due at the beginning of class tomorrow. So you can either work on your homework or your concept check.
Hey, man.